All right, guys, welcome to lesson 5 from unit 14, our last lesson for this unit. We're going to continue our discussion about parametric equations today. Now, last class, I gave you guys an equation, let's say, in rectangular form. Let's say I gave you that. And then I told you that t was equal to something, right? And our goal was to change the rectangular form into a parametric form using this parameter. That's what we did last time. Well, today we're going to do the opposite of that. I'm going to give you an equation in parametric form and ask you to change it into rectangular form. After that, we're going to look at that equation that we created, and we're going to decide whether that is a parabola, a circle, an ellipse, or a hyperbola, and then we're going to graph it. Okay, so that's our goal for today. It's just kind of pulling everything together. This unit was about conics, and we threw in some stuff about parametrics, and so today we're going to see how those two things kind of come together and describe similar things. So before we begin, it might be good to review this slide, which I shared with you guys back in lesson 14.3. All the different conics that we've learned and how you can tell them apart. Okay, parabolas have only one variable being squared. So in this case, only the x is being squared. In this case, only the y is being squared. And so for parabolas, only one variable is squared. That's how you can tell you're looking at a parabola. The rest of them have the x's and y's being squared. Now, hyperbola is the next one to point out because it's kind of unique. With a hyperbola, one of the expressions has a negative in front. One of the variables has a negative. Okay? So with a hyperbola, one of them will have a minus. Now the other two are a little bit more difficult to tell apart from each other. We have circles and ellipses. They both have positives only. So we have a positive x minus h, we have a positive y minus k squared. And they also both have the y and the x squared. So what's the difference? The difference is that with a circle, it equals the radius. Whereas if you wanted to divide by r squared, you could write it like this, where this is a 1 instead. So what makes a circle different from an ellipse is that the x and the y have the same coefficient. Whereas on an ellipse, the x and the y will have different ones. Okay, so that's how you can tell a circle from an ellipse. So these are all the conics we've learned how you can tell which one is which. Okay, so having reviewed that, let's go ahead and jump into our first example. Example 1 says, write the parametric equation in rectangular form and then use that to graph it. Okay, so step 1, let's change it into rectangular form. Now this is the new part for today's lesson. The rest of it's review. So this is the new part. The rest of it will be review. All right, so how do we change a parametric equation into a rectangular equation? Well, it's going to be a two-step process. The first part of that is going to be solving for t. Now you could do that with either the y or you could do it with the x. It doesn't really matter. Let's go ahead and I'm just going to use this equation here. So if I wanted to solve for t, get t by itself, what would I do? Well, I would square both sides to get rid of the square root. And that means that t is equal to x squared. The next thing you're going to do is you're going to substitute. Since t is equal to x squared, I can replace this t with x squared. Oops. So I'm going to replace the t with x squared. Okay, so that's step one. I'm done. This is now a rectangular equation here. So that's the end of step one. Now, step two. We want to decide what type of conic is this. And so we also want to and once we do that, we're going to rewrite it in a in the form that we saw on the last slide. So what kind of a conic is this? Well, as you guys can see, there's only one variable being squared. So since only y is squared, that means this must be a parabola. But we need to write this now in the right format. Okay, for parabolas, you really have two choices. Parabolas can look like this. Or parabolas can look like this. And it really just depends on which variable is being squared. Now in my case here, I have the x's being squared, so I'm going to be using this one. Okay, so I need this to look a little bit more like the top. It doesn't quite look right now. So let's go ahead and do that. The first thing I'm going to do to get it in the correct format is I'm going to move this 4 here to the other side. There's supposed to be a negative on that x squared that I left out. And that's pretty much it. I'm done. It doesn't look right, but I'll show you why it is right. The y minus 4 should have something in the front of it, right? But there's nothing there. But if it's not there, what can we assume that number to be? It would be a 1. Also, our x should have something being subtracted from it. But since there's nothing there, what would that be? It would be a 0. Okay? And there actually is one more thing. We don't want anything in front of the x minus h squared. So I don't want that negative there. So what I'm going to do is I'm going to divide both sides by a negative. And the result will be negative 1 y minus 4 equals x minus 0 squared. Okay, so that's step 3. And now the last thing we're going to do is we're going to go ahead and graph it. We're going to go ahead and graph it. So I'm out of space, so I'm going to delete this. If you need to pause the video here to finish writing, go ahead. So I have negative y minus 4 is equal to x minus 0 squared. Now, if you don't remember how to graph your conics, you'll want to look back at your lessons 14.1 through 3. For parabolas, that was lesson 14.1. So to graph it, the first thing you do is identify the vertex. The x value is 0. The y value is 4. Next, we have to decide what kind of a parabola is this. Is it a happy face or a sad face? Or is it a right or left parabola? Well, since it's the x squared type of parabola, it's one of these. And now more specifically, we could decide that it is a sad face parabola because there's a negative here. So my parabola is going to look like that. Okay? So a 4-step process there. Let's go ahead and try one of these. We'll do it in steps, okay, because there's a lot going on here. So the first thing I'd like you guys to do for your student practice for step 1 is to write it in rectangular form. So follow the example on the last slide and see if you guys can rewrite this thing in rectangular form. Now, just so that we can be in agreement, this time, instead of getting the x or the t by itself with this one, let's get the t by itself with this one. We'll see what you guys can get there. All right, so there is step 1 completed. Once you get the t by itself using the y equation, you could plug in y plus 1 here, and you get this, which simplifies to this. And to get rid of the square root, we square both sides. All right, so go ahead and pause the video here if you got that, and let's move on to step 2. So pause the video and try step 2. All right, so that's a parabola because we have an x being squared and that's it. There's nothing else. All right, let's go ahead and try step 3. So go ahead and pause the video here and see if you could write this parabola in the regular transformational form. When you unpause the video, I'll have the solution up for you. All right, there you go. So that is the result for step 3. We had x squared equals y, right? Well, the variables are separated well. The issue is just that there was nothing, there's nothing being subtracted from the x, so that would be x minus 0. There's nothing being subtracted from the y, so that's y minus 0. We should also have something in front of that y, which would be a 1 in this case. And so this would be the regular transformational looking form there. Last step is to go ahead and try and graph it. So pause the video here and see if you guys can go ahead and graph it. And there's the graph. So the vertex was 0, 0. And since the p-value was positive, it's a happy face parabola. Okay, and there you guys go. So that's one type of problem. Let's take a look at another one. Before we jump into our next one, I want to remind you guys of a few key Pythagorean identities. This is stuff that we saw a little while ago. One of our Pythagorean identities that's going to come in handy is this guy. Sine squared plus cosine squared equals 1. Another one that's going to come in handy is this guy. Secant squared minus tangent squared equals 1. Okay, that'll come in handy for these following problems. So let's go ahead and do example 2a. The parametric equation below is a conic. Write the rectangular form of the equation and determine what type of conic it is. And we can even graph it afterwards. So I think we'll just go ahead and follow the same steps that we did with the last problem, those same 4 steps. Okay, so here we go. Now instead of solving for t this time, what we're going to do is we're going to solve for sine and cosine. Okay, so in this case, for instance, x equals -2 sine of t. I'm going to divide both sides by a -2. So now I have x over -2 is equal to sine of t. And let's do the same thing for the other one. I'm going to divide both sides by a +2 on that one. And for that one, I end up with y over 2 equals cosine of t. Okay, so that's the first part, is to solve for sine and cosine. The second part of step 1 is to use that Pythagorean identity. Okay, so since we have sine and cosine, I'm going to be using this one here. Sine squared plus cosine squared equals 1. Now, what does sine equal? And what does cosine equal? And we'll just plug them in. Sine is equal to x over -2. Cosine is equal to y over 2. And now we square them. So I have x squared over 4 plus y squared over 4 equals 1. Okay, so there's that. That's step one. I rewrote this now as a rectangular problem. So a little bit different than the last one. Instead of solving for t, we solve for the sine and the cosine. So just get the sine and the cosine by itself. After that, we have to use the Pythagorean identities to get it in rectangular form. All right. Let's move on to step two. Step two is to decide what kind of conic that is. So we have x squared over 4 plus y squared over 4 equals 1. Now, notice that both variables are being squared, so it's not a parabola. Notice that both variables are positive, so it's not a hyperbola. So that means it's either a circle or an ellipse. Now, since both of these numbers here are the same, that means that this is a circle. Okay? Now, typically with a circle, we don't like leaving the denominator down there. So what I'm going to do is I'm going to multiply the entire equation by 4. If I multiply here, it cancels the denominator out and leaves me with x squared. If I multiply here, it cancels the denominator out and it leaves me with y squared. And if I multiply here, I get 4. Okay? Now, if you have an ellipse, you don't need to do that step. Furthermore, the equation of a circle looks like this, right? X minus h squared plus y minus k squared equals r squared. So notice I don't have anything being subtracted from the x or the y, so that means that those are zeros. Okay, so step 3 is to write it in transformational form. Okay, so once you've identified what kind of conic it is, you need to make the equation that you have look like the appropriate format. The reason we need to do that is because when we get to step 4, which is graphing, you need it in transformational form to get it graphed right. So when it comes to graphing a circle, the 0 and the 0 are the center. So my center is 0, 0. It's the number you're subtracting from x and the number you're subtracting from y. The radius is the square root of whatever number's over here, which is 2. So I'm going to go out 2 to the left, 2 to the right, 2 down and 2 up, a little farther down, and connect your dots. And there's my graph. All right, so there's the example 2a. So once again, we'll go ahead and do this in steps because this stuff's kind of a lot. So let's go ahead and have you guys do part A, changing the parametric equation into rectangular form. That's the thing where you get the sine and cosine by itself and you use the Pythagorean identity. So pause the video here, give it a try, and when you unpause it, I'll have the answer up for you. All right, so there's our solution. You should have ended up with x squared over 25 plus y squared over 9 equals 1. Step 1 would be to divide by 5 here and to divide by 3 here to get the sine and cosine by themselves. Then we use our Pythagorean identity here, and we replace the sine with what sine equals in the Pythagorean identity. So since sine is equal to x over 5, sine squared becomes x over 5 squared. Same thing over here with the cosine. Cosine squared is equal, well, cosine is equal to y over 3. So cosine squared is equal to y over 3 squared. And then when we square those two things, we end up with x squared over 25 and y squared over 9. All right, let's move on to step 2. Pause the video here and see if you guys can figure out what type of conic is this. Is it a parabola, circle, ellipse, or hyperbola? Step 2, the answer is ellipse. Why is it an ellipse? Well, when you have x squared over 25 plus y squared over 9, both variables are being squared, and they're both positive. And the coefficients underneath here are different. That's an ellipse. Okay? So let's write it in transformational form. Now for part C, there's really only one little thing you have to do to get in transformational form because it's almost there already. So go ahead and pause the video here and see if you could rewrite a little bit. What should an ellipse look like? Fill out all the pieces that it should have in its transformational form. And there's our answer for part C. We were just missing the H and the K, which are 0 since they're not there. All right, we're ready for part D. So go ahead and pause the video here and see if you guys can graph your ellipse. When you unpause the video, I'll have the answer up for you. And there's our answer. The center is at 0, 0. It's the H and the K that we just filled in there. And when it comes to an ellipse, they have an X radius and a Y radius. The X radius is the square root of the number underneath of the X term. So my X radius is 5, so you'll notice that the distance from here to here is 5, and the distance from here to here is 5. And the Y radius is the square root of the number under the Y. So you'll notice that the distance from here to here is 3, and the distance from here to here is 3. Once you plot those 4 points away from the center, you go ahead and connect those 4 points and you have your ellipse. All right? Let's do one more type of problem before we call it a day. This one has secant and tangent in it, for example 3. And what's going to come in handy there is we're going to be, instead of using this one up here, we're going to use this one this time because it has secant and tangent in it. All right? So, but a lot of the steps are the same. So the first part says change the parametric equation into rectangular form. All right, so the first thing that we're going to do here is we want to get the secant by itself. So the first thing I'm going to do is I'm going to minus the 2 on both sides. Then I'm going to divide both sides by 3. And I find that my secant is equal to x minus 2 over 3. We're going to repeat that process for the other one. On this one, we want to get the tangent by itself. So I'm going to add 1 on both sides. And then I'm going to divide both sides by a negative 4. So step 1 is to get the secant and the tangent by itself. And to get it in rectangular form, now we're going to use that Pythagorean identity. And the Pythagorean identity was secant squared plus tangent squared. Actually, take that back. It's minus tangent squared for this one equals 1. So secant squared is, or secant is x minus 2 over 3, right? So I'm just going to plug that in there. Tangent is y plus 1 over negative 4, so I'm going to plug that 1 in here. And then we go ahead and square it. Now for the top, we're just going to leave it as x minus 2 in parentheses squared. On the bottom, we have 9. For the other one here, we have y plus 1 squared over negative 4 squared is 16, and that's 1. Okay, so there's my answer to part A. We've changed it into rectangular form. What type of conic is that? Well, it's not a parabola because both the x and the y are being squared, but one of these expressions is negative. When that happens, that means you have a conic that is a hyperbola. Hyperbolas should look like this. And mine already looks like that. So this is the answer to part C as well. I don't need to change that one at all. That's typically how these ones will turn out. You won't have to do anything with them after you get it in rectangular form. It should be already set for these ones. They just kind of turn out that way. But there it is. All right, now we're going to graph it. For this one, you might want to revisit your 14.3 notes, though, to figure out how to graph it. So how do we graph a hyperbola? All right, so the first thing we want to do is we want to find our center, which is 2, -1. Next, we want to find our x radius again, which is the square root of the number underneath of the x. And I'm going to go left and right 3 from my center. Next, we want to find our y radius, which is the square root of the number underneath of the y's. And I get 4. So I'm going to go up 4 from my center and down 4 from my center. Now, unlike the ellipse where we would connect these dots with a circle, we actually, for the hyperbola, we connect these with like a box. We draw our diagonals, and then we have to decide, is this a hyperbola where it's going to be on the top and bottom, or will it be a hyperbola where we're on the left and right? Well, for hyperbolas, whenever the y is the -1, our hyperbola is going to be on the left and right, so it's going to look like this. Okay, so there's that. All right, so for student practice 3, we'll go ahead and do this in parts again. So why don't you guys go ahead and pause the video here and do part A. When you unpause it, I'll have the solution up for you. All right, so your final answer there should look like this. I'll let you guys study. It's all pretty straightforward and self-explanatory, I think, at this point. The only thing I maybe is worried about is here, there was a negative in front of that tangent, so you divide by a -1. But if you didn't catch that and you just left it at x minus 3 over a +1, it really wouldn't matter because when you square it, the negative goes away anyway. So it's okay if you didn't do that, but technically you're supposed to divide by a -1. But there is the answer. What type of conic is that? Well, we have squares with a minus, so that's a hyperbola again. And as I told you, for these types of problems, writing it in transformational form, it's already done. So we don't have to really do part C on this. But what I do want you guys to do now is I want you to try to graph it. So pause the video here and see if you guys can graph that hyperbola. When you unpause it, I'll have it up there for you. All right, guys, so here's the graph. The center should be 3, 5. The x value of the vertex, the center is 3. The y value of the center is 5, so we have 3, 5, and that's this point right here in the middle. Next, we have our x radius, which can be found by taking the square root of the number underneath of the x. You get 1. And that tells you how far to go left and right from the center. And then we take the square root of the number underneath of the y to find the y radius, which is 2. So from the center, we go up 2 and down 2. We draw our rectangle. We draw our diagonals. And then since this parabola has the x part with the negative in front of it, the little hyperbola shapes go on the top and bottom. All right? And so that does it for that one, and that also does it for our lesson. All right? We'll see you guys in class. Have a good day.